So that's kind of how these things are communicating with each other, I guess, is we have these exec commands, which are actually running, that run all this stuff. Well, I think it'd be fine just to be like, well, I can hook into the editor however I want. So what we're going to do is I'm just going to add a little button up here that will just go through the scene, and it'll maybe call some functions on stuff. We could call a function on the blueprint object if it exists, perhaps. Well, I can actually kind of just leave that as an exercise for later. Alright, so there are a couple of options that I'll write for the future. So we can add a callback in the editor build function in editor build utils, or we could add a button on the top which calls stuff using our plugin. Call a function / broadcast event to trigger build for all objects. That wouldn't be too bad to usually find when you go to sleep to come up with solutions. Yes, that is definitely true. So it's not that we don't have solutions for these things. I just was looking for an easy to hook into thing, because I can always not solve that problem unless it actually becomes an actual problem. You know, like maybe the height map generation is something that is fast enough we can just do it on the construction of the object and not worry about it. You know, just stuff like that. So unless there's some other crazy thing. Alright, so we need to store textures somehow. So like we'll dynamically create these textures, then we want to store them. Is that a render target sort of thing? Alright, let's see. How do we render to a texture? If these static messages are seen, you can set up a render target. You can do this with the scene capture component. This will write what the camera or scene capture sees. That's not really what I want to do. I don't want to write. I want to create a texture at runtime. Okay, so let's see. How do these people do it? Sometimes it's necessary to create a texture at runtime that updates contents, a couple methods. You can create a dynamic uTexture2D at runtime and update it efficiently every frame. Use create transient and copy paste. U4 doesn't support updating sub-regions of a texture, so you have to update the entire thing every frame. So we've got update texture regions. So we might have to do this work to update the textures in C++ land. If you need to create a dynamic texture and update it, single time you can use this method. After the call to lock, you must call update resource. This deletes the RHI texture. If using Slate or Slate viewport to render, you can use Slate RHI for well, that's not awful. We can do that. Alright, so basically how we would accomplish this would be we create a dynamic texture. We would then save it as an asset. So like if we had these static textures that we want to keep around, like we want to just keep them around, we'd actually need to store them as assets, wouldn't we? So how would we deal with that? I mean, it would be like part of the level data if we possibly could. Otherwise, we'd have to store it as a U asset. Alright, so that's not awful. See if there's a way that we can actually do this. I don't want to use U assets if I don't have to. Gosh, I'm not even sure of the exact, like I want to store pre-computed data. So let's see, it's like store pre-computed data for blueprint instance Unreal. Let's see. I mean, I could store the data for the texture just as data on the actual U asset that we have in the level, and then I could use it to create a texture at the start of the level. So we're using dynamic textures, save as texture U asset would be one thing. We could save as part of our current asset, then create dynamic texture at begin play. Save as part of the level data. That doesn't look like we can. No, that's not it either. Yeah, I think it's probably this solution here. We'd save the data as part of the current asset, then create a dynamic texture from that data. So yeah, if we saved as part of the U asset, we'd be good to go. So we want to make like we could make a C++ component, and we could attach to this object, which has like these. We could make a static texture component creator. A static texture, yeah, a texture creation component in C++ land, and we could feed it stuff. So that would be not bad. So we'll create a C++ component texture creator, which can create, update, and expose texture data, and then we can reference that. So that'll work pretty well, I think. All right, so we'll just make this texture creator component thing in C++, and it'll be able to create our dynamic textures, and we'll save the data inside of the instance in the level. And we should be good to go there. Not bad. All right, that's cool. I will be right back. Alright, so I think the first thing we should do is we should actually go make those components. So we'll save everything and start on it. So we're gonna actually do some C++ development today. What a concept. Have not done this for a while. Alright, so we're gonna need a component here. Kind of like this animation controller component. So let's just snag these. So this is going to be the Dashkin texture creator component. Alright, so Dashkin texture creator component generated. Alright, so we don't need this at all. Group Dashkin, blueprint spawnable component. This is going to be U Dashkin texture creator component, which will be a U scene component. Do we need a U scene component on this thing? Because I don't think we need a scene component. Like, the scene component has a transform. This isn't going to have a transform on it, so I think we just need a U actor component. So don't need those events. We don't need any of these like callbacks. Scene component has socket stuff. We don't care about that. Alright, so we're going to need a create texture, or get a create texture. Yeah, we need something like that. Actually, we need like a begin play, end play sort of thing, don't we? Yeah, so why don't we just do a begin play. I guess we don't need an end play, we just need a begin play. Alright, let's see, we're going to need the Dashkin texture creator component each Dashkin creator component, just like this, and we got our begin play. We can just do it like this. Alright, so this will be called on begin play. And let's see, info log texture creator component play call. Yeah, we want to override these because we can. Alright, this should be available and we should be able to spawn this and do all that stuff. So let's build it and see if our component is available for us to actually use. So we will get back to what we really like doing here, which is compiling. Nothing better, right? So add this component. I want to just make sure that it shows up and works and all that stuff. It's been a while since I've actually messed around with the C++ land components. Since we've been doing a whole lot of blueprint stuff, since we actually got out of kind of prototyping stuff and actually into like making game assets. It's incredible how quickly your skills in programming and all that sort of stuff just go out the damn window if you're not doing something every day with it. You're just like, oh yeah. It's just like, what was I doing last time? I don't remember. Alright, so if we add a component here, we want to do the Dashkin texture creator component. So we can just go ahead and save that. So we hit play. Let's just snag our log real quick. And there we go. Our texture creator component play was called, so awesome. We got all that stuff going on. Alright, so we're going to want the this is going to be the flow field static flow field texture creator, and then we'll want to duplicate. We're going to want the static height map texture creator. I don't want to duplicate this again. We're going to want the dynamic flow field texture creator. And we're going to want the dynamic obstacle texture creator. Are there any other textures we need? I think that's all of them. So we'll save that, compile it, and awesome, we'll be able to do all sorts of stuff on this. So why don't we go ahead and see if we can make some textures from data. So let's make a U function that's callable. So texture creation and fetch functions. So how should we have this set up? I think it's going to be like void rebuild texture, or just build texture, and then we'll have like a U function here for like get texture. So let's look up our dynamic textures. Basically, it's a U texture 2D. Get texture. Alright, so we're going to need a U texture 2D pointer. We're going to call this in texture. We'll need a bool in texture built. Alright, so M texture built, false, and in texture null pointer. And this will need to be a U property, I think. So how do we make this transient? Let's see. Property is transient should not be saved, zero filled at load time. So we just, to make this thing transient, we just say that. And since it's using texture 2D, we should just, it'll auto garbage collect itself, I believe. So you don't have to delete the damn thing. So let's implement our functions real quick. And I'm getting super hungry. I'm probably going to have to end the stream here in another half hour or something like that, because I'm just going to die of starvation. And I think I probably won't be back to do more game dev today after that. Alright, so this guy's got update texture. So the article I'm looking at right now is the dynamic textures thing in the wiki. And sorry it's not on the screen, I'm just trying to read what all this stuff does. So they've got like, basically you can create the transient texture using uTexture2D, create transient. We can update the texture, and then we can, there's a method called update texture regions in it, but it's compiled with editor, so update texture regions is something else. So basically what we're doing is we're enqueuing a unique render command. So Okay, so you actually render to this thing using this region data. So you make a new region data object, and then on the render thread we'll go do all this stuff. RHI update texture 2D. So this is just a function that I can actually just use and call. It would be nice if they included an example usage of this function. If you need to create a dynamic texture and update it a single time, you can use this method. Note, after every call lock, you must call update resource. Alright, so it seems like we want to go to our graphics utils and we want to actually throw this thing in there. So why don't we just do that? So we're going to create this function that this guy already made for us. So this will be texture commands. So this will be what? Static void update texture regions. So we pass in all this garbage. Let's check these files out so we can actually edit them. Alright. Call to update a texture. Yeah, call to update a texture. And I don't like copy pasting stuff off the internet. I like to retype it most of the time. So I'm gonna do that real quick here. Mainly because if you don't actually type it out, you don't really know what the hell you're doing. At least that's what I've seen a lot of the time. Texture, MIP index, just say regions. Region num. Regions. Pitch. What the hell is source BP? We'll just take a look at this. I don't know what it's called. Let's just call it BPP because whatever. Data and free. Awesome. I also found it looks like there's another forum post by somebody using this, and they got it working. So there is they posted the full example. So if I have problems, I can refer to that guy's full example, which is pretty cool. I like it when people do that, because then that's kind of one of the issues I have a lot of the time. We'll be like, okay, here's the code, and then like they'll give you the code that actually like does something, but then they don't give you any code on how to actually use it. It's kind of like, it was always a joke in college. It was like, well, error handling is left as an exercise to the reader. And it's just like, well, that's the whole damn point. Like, most of the time, error handling is the hard part, and knowing how to handle errors. Like, somebody will make like an HTTP call program or something and be like, well, this is how you call, a service over HTTP and get a response. Error handling is left to the reader. You're like, well, what do you do if it times out? It'd be like, well, I didn't write that part. It'll just sit there and deadlock your program. You're like, well, shit, that's not good. It's like, well, it's not my problem. I'm like, well, thanks for your crappy example that doesn't help. It also kind of explains a little bit more about how this thing actually works. So when you enqueue the texture for the read, this enqueue unique render command 2-parameter will go right to the texture during the render step. But you might be wondering, well, that means it's not actually going to render the texture until later, which is correct. But that doesn't matter because you've set the pointer to the material already. So in the render command, it's going to render the texture, and then it's going to render the stuff that uses the texture. So even though you don't need to like wait until it's finished, you can just be like, render that texture, and then everybody else can just play nicely during that time. So that's one thing I do need to worry about, is if I'm referencing the data that's in the texture, I can't use the texture itself. I should use a copy of the data which I use to actually make the texture. That's fine. And let's actually just Alright, so what we'll want here is bool rebuild. Yeah, I'm going to kind of skip around here because so if mTexture built and rebuild is false, return. Or otherwise, texture built is true, and we'll call build. So if you call get texture, so if mTexture built equals false, then we're going to call build texture and then return the texture. That way it should never be null, but it might be if something happens, like this returns, whatever. It's not my frickin' problem. It's not, I should say, it's not my problem right now. It will be my problem later. Alright, so I'm gonna kind of copy this. So if texture resource equals null pointer, we're just going to return. I'm going to do a warn log though. Warn log attempting to update texture regions on null texture. Alright, otherwise we need struct. Is this guy declaring a structure right here? Alright, so it's F texture 2D resource texture M texture resource int32 mip index. And I'm one of those people that likes to put im underscores on the front of all variables that are like members of a class or structure. And you can hate me for that. That's okay. A lot of people have hated me for this. But the important part is I do not hate myself. Even if some people think I should. Alright, so we need our update texture regions 2D. It's not regions, it's region. Alright. Unit 32, pitch. Unit 32, sort BPP. Man, I think I learned how to type. Unit 8. And source data. Alright. So that's our structure. So what we need to do is update texture regions data star region dat equals new region data. Alright, so region dat, let's see, m texture resource equals, we'll cast it to an f texture 2D resource pointer, this passed in texture resource. And region dat m mip index is going to be mip index. Region dat m num regions is going to be region num. Region dat, we got source pitch, so m pitch is going to be pitch. Region dat sort BVP is going to be BVP. Region dat sort data is going to be data. Okay, so basically we make this temporary structure here that we create, and then we're going to enqueue this render command. So it's enqueue unique 2-parameter render command. It's going to be update texture regions data. So you're defining in this macro what this thing takes. And I am not sure how this macro really works. But it basically works something like this, where you enqueue this thing, and my question is, what is this update texture regions data thing right here? Is that just the name of this? Is that what it gets translated into? Anyway, this is like what variable to pass in. I should probably kind of organize these a little bit more. But this is like variable type, what it's passed in as, and what to pass in to it. Same here. Alright, so for unit 32 region index equals equals 0. Region index is less than region det or m num regions plus region index. Alright, so n32 first MIP equals what? Region det m texture resource get current first MIP. Alright, so we're going to grab the first MIP off of this thing. Alright, so if our region det m MIP index is greater than or equal to our first MIP, then we do this thing. We're going to call RHI update texture 2D, and we're going to pass in region det m texture resource get texture 2D RHI. Then we pass in the region det m MIP index minus the first MIP. What is this RHI update texture 2D? I'm gonna go look it up. You gotta love the documentation on this function. It says absolutely jack nothing. So it's in RHI command list.h. I guess there's just no documentation on it. It's just MIP index, update region, source pitch, and then source data. And it just does what it does. It updates the texture in 2 dimensions. We have no other data on how it actually functions under the hood other than it does function. Alright, so we're going to pass in m regions sub region index? Yeah, okay, here we go. Region det m sort pitch. This will be region det m sort data. Okay, so we're supposed to add in here this region det m region sub region index dot sort y multiplied by region det m sort pitch and then we're going to add to that region det m regions sub region index dot sort x multiplied by region det sort BPP. Bytes per pixel? Is that what it is? Anyway. And outside of the for loop, if free, then f memory free region det m regions and f memory free region det and sort data. Delete region data. Okay, so supposedly this will update our texture with the data that we pass in and all that sort of fun times. Well, let's compile it and see if we mistyped things. It's been a while since I messed with all this stuff. So it should be good. I expect absolutely no trouble, right? That's right, we're gonna need a size for this thing. Alright, so we need a U property. It's gonna be int32, texture width, and another U property which will be int32 and texture height. Let's just have them be 512 by 512 by default. And let's also have a set texture size function, and 32 width, and 32 height. That's a call to set the texture size. Let's have a bool here for bool rebuild equals true. No, we're not going to have a rebuild because we don't have the data. The data will be fed to us. Alright, so what we're going to do is texture width equals width, and texture height equals height. And then we'll remake the texture object right in there. And yeah, I guess that texture is just going to go into scope. I mean, it could be used. You're going to have to call get texture again and all that sort of crap on it. That's fine though. I'm not too worried about that. Fatal end of file and macro expansion. Okay, so let's take a look. Where... Yeah, it looks like we're missing this right there and that garbage. And of course, it's stuff like me spelling MIP index wrong. Just cleaning stuff up. Let's get this built. Let's do it. Come on. Alright, so let's take a look. Unresolved external symbols. So I do remember this did say we need to make sure that we have things included in our build. Let's see what we've actually got in our build. We've got, they're saying public dependency module names. We need core U object. We need engine. We need input core. We need RHI and render core. Alright, so we need RHI and render core inside of this thing. So if you ever have weird linker errors and you're messing with C++ stuff in Unreal and you just added stuff that might be in a module that you didn't include, it's your build CS file that's going to be causing all that shenanigans. Basically, linker